Okay, so before that works, I just want to apologize first, so I might look a little bit tired. It's not because I partied through the whole night, it's actually because our flight just arrived 6 hours ago, and we were actually 1 day delayed, so if I say something what doesn't make really sense to you during the talk, I encourage you to ask questions, because it might actually be that doesn't make sense. Okay, with that out of the way, hi everyone, I'm Daniel, I'm from Beijing, where I'm researching on industrial communication and automation. In my private time, I'm working a little bit on MRuby, and I would like to share a little bit about a small hobby project I have worked on a couple of last months. So when I just came here, actually, someone asked me with this title if I'm going to make fun of Ruby on Rails or so. Obviously, that's not going to happen. It would be a little bit low taste. We are really going to literally talk about wheelchairs and how to put Ruby on it. And there's essentially two things you should keep in mind for the talk, and I hope in the end for the conclusion, if you do not agree with me, you confront me with some questions. So the first thing is, of course, why should I actually talk about Ruby on wheelchairs? And the second question you should keep in mind is, why should you actually care about this topic? So, as you see, at the moment I can actually work, but obviously for all of us, that's only temporarily. So I was not so fortunate some time ago where I actually broke my ankle. So I landed up in a wheelchair for quite some while, and it was quite painful, but the pain went away with the painkiller, and the doctors gave us a wheelchair, and I thought, okay, that should work. So, well, my wife didn't think so, because she had actually to roll me back all the way from the hospital back to home, and I could easily convince her at that point to actually go shopping to get actually a better wheelchair, so an electrical one. The wheelchair I bought is just actually the lowest type you can have, so you can imagine these wheelchairs are very primitive. They have 2 wheels, 2 motors, have a big battery and a controller. And after using it for a while, I was thinking, it would be cool actually to exchange this controller with something I have totally control of. So that thing cannot be software updated, there can be no viruses on it, so it's leaking a lot of features, so we can improve on that. So as a first start, we had of course to look on what do we want to do. We want to control motors. So before I actually cut apart the wheelchair, I was actually making some tests. Is it actually possible? So the left side is actually a DC motor usually used for the efficiency, and it actually works in a fairly easy way. So you are switching polarity for the direction, and the rest is just power. Sadly, I didn't have something like that at home except for the wheelchair, so I played with a smaller stepper. So a stepper motor is essentially a motor where you have coils you control individually, and the direction is controlled by choosing which coil to activate. So, so I made a small little demo, so I used for that obviously MRuby. I had some small microcontrollers, so Yukio Matsumoto was mentioning small systems and mentioned something like 2 GB or 512 megabytes. But as a matter of fact, these devices here have further something like 192 kilobytes of RAM, so MRI would never work on that. So MRuby is the only choice to go for here, and I actually implemented quite some years ago the IRB for MRuby and ported them also to these microcontrollers. So if you're interested about it, there's actually another talk 2 years ago at RubyConf about this topic. It is actually possible. It's not too difficult in the end, and so I was playing around. It's very comfortable to use the IRB here, which is actually not normal for embedded systems. So many of you might do web development, and you use IRB probably all the time. In embedded system, that's quite common that you actually have this huge cross-compiling cycle, so it takes quite long to iterate. Okay, so I feel confident enough that I say, okay, let's cut my wheelchair apart. And obviously, remember, I could still not walk, so I really had to make that work at this point. So the architecture I changed a little bit, so I dropped away the whole controller. I actually tried in the beginning to automate the controller, but that didn't work out. So I bought a new controller, and I used an STM32, which is a very small ARM processor. So it's not an ARM processor you have in your iPhone. It's something like an ARM Cortex M3, which is very small, very cheap, and very low in power consumption. I put MRuby on that one. The stepping algorithm is very similar to what I had already implemented on the stepper. and it actually happened that it was very easy to get started. And in the end, actually, you will notice that this was actually the most easiest part of all to make it run. So obviously, this is now only done via IRB. Obviously, I do not want to control the wheelchair via IRB. So the next thing was to build up a proper architecture for the wheelchair. So I had a drive system in the bottom. I added, of course, the second motor with a second motor controller. I then decided to use Raspberry Pi, but I also played around with some other microcontrollers in the higher ARM class and put MRI on that one actually, because it's actually powerful enough. And then I had, on top of that one, user interface, which actually could be used by different devices, because I didn't want it to depend just on one device. So it was just an example, when I'm sitting on my wheelchair and I'm trying to debug the wheelchair, my wife can just get out her mobile phone and drive me back home, for example, as a use case. So to go a little bit more in detail for the architecture, so I have the motor controller on the very bottom. I wrote this drive system, some kind of broker. That's maybe because of my background in signaling systems. So I was a little bit afraid what happens if I have a bug in endless loop and the wheelchair just accelerate. So honestly, I over-engineered at the beginning a little bit because I wanted to actually have an automatic braking system if I do not get any controls anymore. Then I implemented a serial driver, which then talks to something called Zare2Net. It's actually a very interesting standard program. So it's just a C program you run on embedded devices or Linux systems, which actually maps serial communication to UDP or TCP sockets. And with that, you actually modularize very nicely away the whole drive system. So I could actually start hacking in the beginning just on my notebook, and in the end, after the code worked, I actually dumped it onto the Raspberry Pi. Then I used Sinatra, because I actually not really good at web development, so it was the easiest choice for me. I wrote a small little website to generate into the user interface. And then I actually controlled it via JavaScript. And with that overall, I could now actually go out and drive around. That actually worked pretty well because actually after just several days after I finished it, I was already healed, so I could walk again. So at that point, actually the talk would already be over because after I didn't need the wheelchair anymore, it just ended up in a corner. But as a matter of fact, Destiny came and I broke something again. But it's a little bit more flexible. This time actually I broke my tooth. Which is fairly more painful than actually the ankle. So luckily again, the doctors gave me some nails and painkillers, and with the painkillers in action, I had this high feeling that, wow, now I have my own wheelchair. That's not a problem at all. I don't have anything to worry. But as a matter of fact, now I actually depend on this thing. It turns out that you actually have a lot of problems with something you just make for fun, and then something actually you really depend on it. So I could not just walk away after my Ruby program crashed. So there were several issues. I just mentioned 4 here. So for example, using a touch interface to control actuators is a pretty stupid idea. It's fairly unprecise. You have a very bad feedback. You can hardly get out of control. Then the wireless interface actually, it's unstable sometimes. So sometimes the wheelchair started to drive and I could actually not stop it. Another thing, what I didn't consider is actually that the way I controlled the DC motors actually worked on giving a constant power, and that actually depends if the ground is steep or not steep, is now falling down, so the wheelchair actually doesn't have a constant speed. It's an issue. And the thing I want to go more into detail is actually the question, how far can I actually still drive? So maybe some of you have heard about this new thing like electrical cars and this concept of range anxiety. So that you have a car and you're actually afraid, can actually the battery last until home or until the next power source? Actually, you have the same with a wheelchair. So how to look at that one? Well, I was thinking, a wheelchair should have a battery indicator, so I said there should be nothing to do for me. So where's the battery indicator of my wheelchair? Well, it is there. And there's a problem here, as you might remember, I actually made some decisions to actually remove that stuff. So at that point, I could of course admit it that, well, maybe it was not such a pretty smart idea, and the guys who designed the wheelchair had actually already thought about a lot of things, and I could just reconnect it. But let's not admit the mistake. Let's just build my own battery indicator. So how does that work? So very simple. Don't go into electrical details here. There's just one problem. The battery has 24 volt, and you can actually indicate the load of a battery by looking at the voltage and the voltage drop if it gets some load on it. The problem is with mRuby and the ARM processor I'm using, I can only indicate 0 to 3.3 volt. So what you are usually doing then is to implement something called a voltage divider. A very simple circuit, which essentially just maps 0.3 volt or 0. To 2.8 maybe, depends on the resistor you use, to the 24 volt. You have a curve, and the curve will be linear if all the components are proper, but how the curve looks is actually probably someone who knows really deep into electrical engineering could actually mathematically calculate that easily. I'm not that kind of guy, so I experimentally actually derived that. So what I used here is, again, of course, Ruby, and again, it's very beneficial to have an IRB running on the microcontroller, because you can just run your averaging algorithm. You can switch it together with a programmable power supply. You can set a voltage, then measure, then get the approximate value, put that into a list, and then actually derive a formula from that. From there, it's straightforward. So you derive the way to get actually the absolute voltage, and in the end, you have a very simple Ruby method to actually get the relations between 0.3 to 0.24. In the end, again, to check if that actually works, I use again the MIRB. So I use this programmable power supply. It doesn't matter. The battery would be the same, and so I can change the voltage and I can indicate it. And of course, due to the reason that it's pure Ruby, I can also use all kind of Ruby code, which is allowed by mRuby. So that I can also check dynamically to see. Okay, so with that, one problem less. Then there is a lot of other issues I had, but just to mention, so for the touch interface, I went to a gamepad. It seems to be a little bit more optimized. For the redundancy, I actually used an LTE modem. So you can actually, if you use two LTE modems, and you made a peer-to-peer connection, you actually short-circuiting the routing, so you actually only go over the base station and the EPC of the provider network, and the latency is quite low, so they actually work quite well. And for the steepness, I actually worked on an odometer, which actually counts how much the wheel is actually turning, and with that I can estimate the speed. And with that, I actually became not only comfortable of transporting myself actually to now with the wheelchair, but oh, it doesn't play. That does that. Oh, okay, good. Yeah, okay, it's not much to say. Just now you see that the wheelchair will drive. So I could not only transport myself, I could also transport other things, like here, for example, my iPad or some Coke, or I could chase my son. All the usual things you would do now with a wheelchair. Okay. And at that point again, when I reached that state, my foot was nearly healed again. So essentially, I didn't need it at that point anymore. And now I could put it again into the corner and let dust settle on it. But I would expect, because I didn't become smarter over time, that the next will probably come soon. So I should prepare for that. So I was wondering a little bit, what is next? What should I look on it? One thing I noticed is actually navigation. So as a matter of fact, if you do navigation for cars, for bikes, or for pedestrians, necessarily this is not the optimal way to use it now for a wheelchair. Obviously, not everywhere you can walk, you can use a wheelchair. Not everywhere you can use a bike, you can use a wheelchair. You need specific navigations for wheelchairs. It's obvious. For that, I actually use something called Openstreetmap, which is also a Ruby application. Probably a lot of people have heard of you. It's actually the target of building an open database of the whole world. And the great thing about this is actually that everybody can contribute to it, and you can define your own text. So I can say what the service is. I'm here. So the guys who actually maintain that do not give me any regulations what I can use. So there is already one project from Germany which is using that quite interestingly, which is called WheelMap. So WheelMap is a project where now people are encouraged to map the accessibility of locations. So for example, if I look around me here, this would be quite bad accessibility because nobody with a wheelchair will get up these stairs. And this is crowdsourced, and they're actually tagging it in their own application and then push it back to Openstreetmaps. On the other side, with this information now, you can actually do interesting things. So there's this service called Open Route Service. And they're actually using information from OpenStreetMaps, information you have feed into OpenStreetMap to actually calculate a path. So where I now see myself, and it's actually, I would like to use the platform I have to actually feed the system. So I experimented with some vibration sensors and camera systems to actually detect the surfaces I'm driving over and actually feed that back to actually increase the database. So at the moment it's Open Route Service, which then looks approximately like that for wheelchairs, is mainly focused on Germany and a little bit more like Europe, but it's not worldwide, so we need to increase the database for that one. And as you see, you get a route calculated from A to B, and on the left side you also have the material of the surface, which makes a big difference. So obviously with a wheelchair you prefer something like asphalt or concrete and not like these cobblestones, which are now also quite common in Germany. So again, wheelchair optimized navigation is one thing I'm working on. Another thing is vision. So if you are like me and you actually never used RC cars as a kid, you might actually use the wheelchair a little bit too agile, I would say. So you will at one point for sure bump into something. If you are happy, then you just bump into a wall. If you're unlucky, you actually bump into some other people and maybe move them even in a wheelchair. So I have to consider protection of the wheelchair, obviously. So one thing I looked at is LiDAR systems. So LiDAR systems, you maybe know that these Google cars, for example, use them. So it's a light emitting device which gives you distance measurement from a central point for 360 degrees. So there are a lot of them available. As a matter of fact, I didn't find a single driver in Ruby. And I thought, okay, that has to change. The interface is actually quite simple. So they usually provide a serial interface. You can control the motor, and then you actually get readouts over the 360-degree angle about the distances. And so after working on that, what I can now do is actually, I have the wheelchair, and I actually can detect obstacles moving around the wheelchair. So that's of course quite beneficial if you do not want to bump into something. You can just lower the speed the closer you get to an object, or you can stop if the object is too close. The same thing is of course not only for static environments, but also for moving environments. So obviously if you're driving around, you also would like to not collide with other objects, so you need to have some kind of vision, which is of course, it's the same system, just a different use case. So you can see there is actually some things you cannot really see, like things which are reflective through, but in the real environment it actually works quite well if you just estimate a little bit conservative and better stop than proceed. Okay, so with that said, concerning conclusion here, so I have essentially two things to conclude. First is about the Ruby ecosystem. So, I mean, Yukio Matsumoto has talked about MRI, how it's improving over time, mRuby and JRuby. So my personal ecosystem looks actually like that. So I have this Ruby wheelchair, I have implemented different things which have different kind of complexities, different kind of needs. The data quantity of a drive system and the complexity is very low, to be honest. It's very simple code. Then you go further and you have Ruby applications like Wheelmap and Openstreetmaps, which have a huge amount of data because Openstreetmaps want to categorize the whole world. So the complexity level is different. But as a matter of fact, today we can do on all these levels solve our problems with Ruby. We have, of course, the MRI as the baseline, which gives us the most correct Ruby. But then we have JRuby and mRuby, which is for me the more important one. Which actually does something to move Ruby into new environments. So one of my conclusions would be consider Ruby maybe for new areas where you didn't use it before. I actually do not see that many limits which Ruby cannot be used. And the last conclusion is how to improve from here. So I personally would be very happy, and my whole flight and everything would be completely well paid off if just one of you, after you come back home to your home country, would actually just go to wheelmap.org and maybe just take one element. So just say your nice coffee or so, what kind of entrance barrier they have. So that would be already great. But as a matter of fact, tagging the world is actually not solving a real problem. It's just documenting our problems. What we really have to think about is, will you improve the environment for people who are not able actually to navigate? So, and as a matter of fact, that's a difficult problem. And the reason why it's a difficult problem is because wheelchair users are a minority. So, I mean, I do not want to do finger pointing, but I can talk for myself, I would not have cared about Wheelmap or wheelchairs if I would not have bind to a wheelchair. So from that, I conclude actually to solve this problem is actually to put everyone on a wheelchair. So now you would maybe be a little bit confused, or maybe hopefully nobody's offense, but if, then please wait a moment and let me explain. So obviously I'm not suggesting to go around and break everybody's leg. Obviously, that would not scale for me. What I suggest, what I suggest is that we change the concept of a wheelchair. So at the moment, most people consider it a hassle. So it is uncomfortable to use a wheelchair. Why can we not think about a wheelchair as something which actually improves our life? For example, in these days at my work, I'm actually from time to time use the wheelchair to sit at my desk, and I'm driving then maybe to the lab or to the fridge with my wheelchair. And I can do that more comfortable because I do not have to move, and I can make that faster. And I'm actually good on track that I can actually even automate that. So in the future, I do not even have to think about how to come from A to B. So pushing our way forward that actually people who can walk decide to use a wheelchair instead might actually solve the problem we have of the missing infrastructure, because if everybody needs to use a wheelchair, then they will also push for improving that it can be used proper. And with that said, thank you very much.
Cool. So, do we have any questions for Daniel? Yeah. We always have a question.
Very curious person. Are you doing motorcycle races or something? Because how did you break your your leg twice?
No. It's maybe, I should probably not admit that, but I have these anger phases, and if someone showed these XKCD, so if someone is wrong on the internet, I do sometimes stupid things, like, for example, hit a wall. Okay. That's not a smart
kicking
thing.
Walls. That's better than kicking people.
I didn't target for the wall, but it was just there in the way. Yes, I'm feeling a little bit embarrassed about it though. But I didn't make any weird. No.
Impressive.
Yeah.
All right. Any more questions? Yeah.
So I've got two. The first one is you had a joystick. Did you have a second port for PvP as well, so that other people could?
You can now two people could control at the same time, but the inputs would be conflicting, so the result would not be what you want.
So that, I apologize, that was the facetious question. The second one is in terms of like expense and difficulty. How hard was this for you to put together overall?
Okay, expensiveness, this is actually one part, sorry to not mention that. So one thing is actually also this whole wheelchair industry needs some kind of disruption, because with the things I have just bought one off, I can actually build a wheelchair for half the price what a usual electrical wheelchair is built these days. I'm wondering if it's something like a monopoly thing. I do not really understand why they are so expensive. But with all these features I have here, I still end up cheaper than electrical wheelchairs, which is maybe something like 900, 1000 RMB, which translate to maybe 100, 120, 140 US dollars, something like that, yeah. Roughly.
Yeah. Yay, patents and regulatory capture. Thank you.
Okay. Anyone else? Yep.
You mentioned that in the Openstreetmap, there's a log about the material of the ground, and were you managing to like use some kind of detection to detect like the material?
Oh, sorry, I didn't understand the question. So yes, there is. So you can define whatever you want in OpenStreetMaps as essentially a wiki for maps, but I didn't understand the question.
Oh, did you actually made it so you can record what's the ground underneath you?
Yeah, okay, I understand the question. Okay, yes, so I added a GPS system to it to track the location, and I could mark specific spots as, for example, creating one example, a high vibration, a low vibration, but that actually is not sufficient. So that's the reason why I said that I have to combine it with a camera system, because vibration you can have not only because the surface is horrible, but because maybe there's some other stuff on the ground which maybe are temporarily. So I worked on it, but it's actually a hard problem. So I would like to do that, and obviously if in the future everyone would be on a wheelchair and everybody would collect this data, that would be obvious to do, but at the moment it's something to play, but obviously there's not much value if only my own wheelchair is creating this data.
Oh, thanks.
Okay. Any other questions? Oh.
Hey, so you use this gamepad to control the wheelchair, and I'm wondering how did it work in the crowd? So on the video that you show, I saw that it wasn't perfect controlling.
The video, and I still use the other one. Actually, the steering you saw in the video, the problem is actually the odometry. So actually, the wheelchair is not stable for both wheels. So one wheel. How do you call it in English? Vibrates a little bit, so it's flickering. So even if you drive straight, it will diverge to one direction. So that's a problem I want to solve with the odometer, which actually counts the wheel rotation.
Okay, so there was no problem with responsiveness, and even like, I don't know, if you were in the crowd, you could actually use, could control the wheelchair with your gamepad without being worried that it will accidentally bump into someone. I was wondering if in the crowd you just switched to manual steering anyway, because it was more convenient.
You should probably be worried, but I have somehow maybe a deficit on worrying about things. But yeah. I mean, again, I'm living in Beijing, so I do not drive that through Tiananmen Square, so because they will shoot me down immediately, or I will not drive it through rush hour. So, it's a certain, and of course, I do not chase my son. I just want to say that, so that nobody is reporting me to the government.
Sure, thanks.
Okay, I think we can take one more question if there is any. No? Oh, okay.
So now you've managed to somehow remote control your wheelchair. When is autonomous wheelchair coming up? Autonomous wheelchair, when will it come up now? Autonomous stuff?
Autonomous. Okay, good. Again, that's on the plan. So with the leader system now, I actually can create a proper SLAM system. So a system where I actually map an area and then can locate myself from the surroundings and then navigate myself inside of that. So what we are doing actually at work for playing is to map our floor like that, so that I can at least navigate from point to point. But that's very simple autonomous. So there's nothing to do with these fancy machine learning stuff. So just a simple path routing and then following. So, but that's coming.
All right, I think that's all. Thank you very much, Daniel.
Okay.